Okay, so here in this video, I'm just going to do a little rewind here and prepping for our mid-year exam coming up, and we'll take a look at 6 problems each time. So the first thing is graphing these basic functions again, and I could see that my vertex is 0, -2. And then guys, just go right to 0, -2. And if you want to build a table of values like x and y, that's cool. I'll pick 1, and I'll put that in for x, and I'll get 0. And if I pick here -1 for x, I'll also get 0. And it's a concave up looking parabola, and there it is. Domain is all reals. The range, though, we should know is from -2 to infinity. Here, the vertex would be 0, -4. Just doing the a's and the b's together. 2, 3, 4. Build a t-table if you want. You can't pick -1 for x because it's not in the domain. You can't take the square root of a negative, but I can pick 1. And the square root of 1 is 1, times 2 is 2, minus 4 is -2. And I'll pick 4. The square root of 4 is 2, times 2 is 4, minus 4 is 0. So I'm going to get 4, 0. Shape it from where I started to where I'm going. All right, in number 2, let's factor completely. So we're going to take out an x, and what's left is x cubed minus 1. But guys, this is a difference of 2 cubes. So it's x minus 1, square the first, multiply these, but change the sign, and square that last. Here, I'm going to try taking out an x, and what's left is this trinomial, but you know you can't stop there. See if you can do reverse FOIL. Don't try those other methods. Just go right to reverse FOIL. How do we get a 3x squared, a 3x, and an x? Factors of 8 are 4 and 2 as well as 8 and 1, but I'm going to try the smaller ones here. So let's put a 4 here and a 2 here. Let's see if that works. That would be -6x, right? Plus 4x is minus 2x. Oop, and I think I got the right combination. So there is my final answer to that one. Here, to solve these equations, I'm going to add 4 to get 9. Divide by 3 and get 3. And you square both sides. And then I'll add the 1 to get 10. Here, I'm just going to add 12 to both sides to get the square alone to get 36. I'll divide by 9 to get 4. And then I'll take the square root of both sides, but plus or minus it. So the square root of 4 is 2. So it's plus or minus 2. But you can't stop there. X minus 1. I'm just going to add the 1 over. So I'm just going to add this 1 over. Plus or minus 2 plus 1. So 2 plus 1 is your 3. And -2 plus 1 is your minus 1. Over here in number 4, we got to do the number line test. It's an inequality. It's already set to 0, and it's already factored, which is pretty nice. So my critical points are 0, 1, and -3. So -3, 0, and 1. Everything's an open circle because there's no equal to. Now, what's the test point to the left of -3? Pick -10. So put that in for x. That's -10 times a -11 times a -7. That's a negative. An odd number of negatives multiplied as a negative. And then I'm going to see how the signs alternate because all the factors of an odd multiplicity. So these are all a factor of 1, a multiplicity of 1, sorry. So then, but just the factors appearing once, though. So where am I less than 0? Negative infinity to -3, and then from 0 to 1. In part B, x squared is greater than or equal to 9. Let's subtract the 9 to get 0. And the temptation on this problem is to always not factor into the number line test, but you have to. Any non-linear inequality, you're doing a number line test. So I subtracted 9. It's a difference of 2 squares. And my critical points are 3 and -3. Make a number line. This time it gets a closed circle because of the equal to part. And guys, what's a test point to pick to the left of -3? -10. Put that into here, I'll get -13. -10 plus 3 is a -7. And a negative times a negative is a positive. If I pick 0, 0 minus 3 is a negative, 0 plus 3 is a positive, and negative times a positive is a negative. And the other one will be positive. They're going to alternate signs again because of the fact they're odd multiplicities. Where we greater than or equal to 0 is where the number line is positive. So that's from -infinity to -3 bracket in union with 3 to infinity. And number 5, function evaluation. I probably should have put this on a separate page, right? So I'm going to replace x with x plus h. We've been doing this quite a bit, but this is building somewhere to later in the year. I'm just going to replace x with that. But some of you on your last exam maybe or quiz, you forgot to distribute the minus sign through this function. So when you have minus f of x, that means everything here has to change to its opposite sign. But now you have to simplify this. You have to square this. And that is, when you FOIL that out, sorry to be quick, is x squared plus 2xh plus h squared. You got to FOIL this out. Then I'm going to times everything through by 3. So it gets a little tedious, but you can do it. Just keep pushing through. Minus 5x minus 5h plus 3 minus 3x squared plus 5x minus 3. Like some of you know in sports, you don't get stronger by playing always the weaker teams. You don't get stronger by always doing the easier problems. So these x squareds divide out, or they don't divide out, they add to 0. And then these x's. And then my final answer is 6xh plus 3h squared minus 5h. And this is pretty easy. I'm going to start with the inside. Guys, g at 2 means 3 times 2 minus 2, and 6 minus 2 is 4. But then I put that 4 into f. And 4 squared is 16 times 3 is 48 minus 20 plus 3. And what does that give me there? 28 plus 3 is 31. And the last two problems here, I'm going to graph this angle. 3 pi over 4 puts me here. That's 3 pi over 4. My reference angle is pi over 4. And my sides are 1, 1, and root 2, but that's a negative side. Sine is y over r, so it's 1 over root 2. And the cosine of pi. Pi is a quadrantal angle. Cosine is just simply the x-coordinate there, which is -1. Okay, so I hope that helps you review some of the algebra things we've been talking about since the beginning of the year, and I'm trying to put it together and for things we need in the future here. So some pretty nice problems there. I hope that helps.